A modern jet breaking the sound barrier is an explosive, visceral display of sheer aerodynamic force and power. During the mid-20th century, across the Earth, rattling windows and disrupting communities miles below its flight path. Because of that noise, governments globally outlawed overland supersonic flight entirely, halting the expansion of commercial high-speed travel. Cutting global travel times in half today requires more than just raw power. It requires a design that bypasses the traditional physics of sound. When a jet hits Mach 1, it travels faster than its own air pressure waves. Those waves pile up tightly at the nose, merging into massive shock waves that slam into the ground as an explosive double boom, known as an N wave. NASA's Quest mission is targeting this specific physical bottleneck with a highly specialized tool, the X-59. Loheed Martin built the X-59 as a single-seat research aircraft designed specifically to challenge the physical and legal boundaries of that acoustic wave. This top-down schematic reveals the X-59's custom-built geometry. The elongated proportions are shaped geographically from front to back to keep shock waves separated. The manipulation of the air begins at the absolute front of the aircraft, with an exceptionally long, needle-like nose. Stretching forward, the nose forces a single shock wave to form at the tip, keeping it detached from the main fuselage's aerodynamic forces. Initiating the wave early spreads the pressure change over a vast distance, preventing the sudden acoustic spike characterizing a traditional boom. By isolating the first point of impact, the nose dismantles the boom before it builds momentum. This side profile schematic outlines the aerodynamic consequence of that long nose. The cockpit must sit low, embedded deep inside the fuselage. Sitting this far back and low into the frame makes installing a traditional forward-facing windshield impossible. The Concord mitigated a similar visibility issue using a heavy droop nose that pivoted downward. The X-59 design avoids that extra weight and drag. Instead, the pilot navigates using the External Vision System, or XVS. The XVS relies on a forward-facing multi-camera setup. It feeds live video and flight data into a 4K monitor, acting as a virtual window. Removing the glass canopy is a strict engineering requirement, as any disruption to the smooth outer contour would alter the continuous airflow needed to silence the shockwaves. Moving back, the swept wings and tail generate their own distinct smaller shockwaves rather than letting the air consolidate into a single pressure wall. Powering this long aircraft requires the GE F414G 100, a heavy thrust engine modified from military fighter jets. The X-59 utilizes an unconventional placement for this power plant, mounting the engine on top of the aircraft's main body. Placing the engine above the wings makes the flat aft deck act as a physical shield. It bounces the mechanical noise and the exhaust plume upward rather than down toward Earth. While the Concord hit the ground at 105 decibels, the X-59's separated shock waves are engineered to reach the surface at roughly 75 decibels. The culmination of this front-to-back anatomy transforms an explosive crack into a barely audible thump. Successfully engineering the aircraft is only the first phase of the Quest mission. By 2026, the X-59 is expected to cross Mach 1, initiating a phase where it flies over selected U.S. communities for real-world acoustic testing. Ground sensors will measure the exact acoustic pressure of the thump, while NASA surveys the residents below to record how they perceive the sound. The objective data must be supported by the human response. If the communities below find the noise objectionable, the design fails its primary objective. This project overview slide outlines the mission's central product, a comprehensive dataset designed to give international regulators the scientific evidence they need to modernize flight noise laws. The resulting database of community responses will be provided to regulators at the FAA and IKO. The goal is to use this scientific evidence to establish new noise thresholds that will allow the overland supersonic ban to be lifted. Regulators adopting these standards would allow a next generation of commercial airliners to utilize the X-59's aerodynamic footprint. Success in the Quest mission means passengers could cross continents in half the time, while the world below hears nothing but a whisper.